Welcome to today's chemistry lesson. Have you ever wondered why salt in the kitchen gets clumpy when left open to the air? That's hygroscopic behavior in action. Hygroscopic substances, like salt, have the remarkable ability to absorb moisture from the atmosphere. Unlike some materials that dissolve into a liquid when absorbing water, hygroscopic substances remain solid. Take quicklime, for example. It's a solid, but when exposed to moisture, it absorbs water without turning into a liquid. This is a characteristic that separates them from deliquescent substances, which can dissolve when they absorb too much moisture. These substances can be amorphous solids or even crystalline solids depending on their nature. In the lab or industry, we see examples like anhydrous calcium chloride and concentrated sulfuric acid, both of which absorb moisture to perform their tasks efficiently. Let's dive deeper into the properties of hygroscopic substances. Imagine a dry day when you open a packet of desiccant, a substance that keeps things dry by absorbing moisture. These substances actively pull water vapor from the air, helping maintain dry conditions. For example, when you store a desiccant like calcium chloride in a sealed container, it keeps the air dry by pulling in moisture. But how do these substances work? When substances like concentrated sulfuric acid absorb water, they form hydrates. That's when water molecules chemically combine with the substance. This process is not just a curiosity, it's key to many industrial processes. For instance, sulfuric acid is used to dry gases in industrial settings, ensuring no unwanted water vapor interferes with chemical reactions. Now, let's talk about drying agents and desiccants. These are substances that play a crucial role in removing moisture from the air or other materials. A drying agent like anhydrous calcium chloride absorbs moisture from gases, keeping them dry for further use. Desiccators, which are used in laboratories, rely on substances like calcium chloride to create a moisture free environment. This is especially important when working with chemicals that are sensitive to water. Imagine trying to preserve a precious metal in the lab. Without a drying agent to keep the atmosphere dry, even tiny amounts of moisture can affect the material. In short, drying agents are the unsung heroes that help us control moisture in experiments and industrial processes. Dehydrating agents take moisture control a step further by removing water that's chemically bound within compounds. You might already be familiar with sulfuric acid, which not only absorbs water from the air but also removes chemically combined water from substances. This makes sulfuric acid a powerful dehydrating agent essential in chemical synthesis. Take glucose, for example. When glucose comes in contact with concentrated sulfuric acid, it undergoes dehydration, breaking down into carbon and water. This reaction is an example of how dehydrating agents can drive chemical changes by pulling out water molecules from compounds. The use of these agents extends beyond the lab. They are critical in the production of certain chemicals and in keeping materials dry during storage. Now, let's take a look at some common drying and dehydrating agents you might encounter. Fused calcium chloride, for instance, is a deliquescent substance. That means it not only absorbs moisture but also dissolves into a liquid as it absorbs more water. Concentrated sulfuric acid, as we've already seen, serves as both a drying and dehydrating agent, crucial in both lab and industrial settings. Fused phosphorus pentoxide, another powerful dehydrating agent, is used when a more aggressive moisture removal is needed. And let's not forget about quicklime, which is used in drying gases in industrial processes. Whether in labs or factories, these agents help ensure we have dry conditions for the reactions we need. As we wrap up, let's review how all of this ties together in the real world. Hygroscopic substances and drying agents are essential in many industries, from pharmaceuticals to food preservation, and even in maintaining dry conditions during chemical manufacturing. They're also used in everyday life, whether it's preventing rust on tools or drying out the air in a package to preserve moisture sensitive products. Understanding how these substances work is not only fascinating but also helps us apply chemistry to improve processes and products in everyday life. So, to sum up, drying agents and hygroscopic substances are key players in keeping moisture under control, making our world more efficient, and even preventing damage to valuable materials. See you in the next lesson.